Okay, welcome back, and now we're going to talk about existence of limits. So we're going to start with an example and show you when we see that a limit does not exist. Okay, so for example, we want to find the limit as x approaches 0 of this function sine of 1 over x. Now, as we can see here, as we do the same table method, we look at values coming from the left and then values of x coming from the right of the a value, which is 0 in this case. We see that, notice that the values of either of these doesn't seem to be approaching the same value. In fact, they're the opposite sign of each. Okay, so we suspect that this does not have a limit. Now, if we take a more systematic approach, and let's put in things that we know will give us a value of sine. For example, we could use this sequence of values. So we could use x that has these values. Oops. Right? Because if we stick these values in here, we get the reciprocal. So that means we'll get f of x. What we'll have is we'll get sine of pi over 2, right? And then the next one will be the sine of 3 pi over 2. And then, of course, this will become sine of 5 pi over 2. And what happens is we get what? What's the sine of pi over 2? That's going to be 1. What's the sine of 3 pi over 2? That's negative 1. What's the sine of 5 pi over 2? That's 1 again. And so we can see absolutely that this does not have a limit because it's just bouncing back and forth between 1 and negative 1. Okay? And so what does this look like? Well, let me show you what this looks like on a graph. So if you were to graph this thing, this is what you would see. Something like that. So what happens is as you get closer and closer to 0, it just keeps going back and forth between 1 and negative 1 rapidly. Okay? In fact, it goes back and forth so fast that it's indistinguishable. Okay? And so that's an example of where the limit does not exist.